Okay, today, this is our last new lesson before the quiz. Okay, so new lesson today. I do not see you on Monday. Is that right? Uh, sorry. I do not see you Friday. I see you on Monday for the review. The quiz is on Tuesday. Okay, and I don't know. So you'll figure that out. So again, I see you on Monday and Tuesday next week. And then I think there was another one, but it'll be after the quiz. Okay? So last year, we had the unit test. The unit ended right before spring break, but spring break was a week later, so we could not get everything in. So we'll have quiz number 2. This is our longest unit, and then we'll come back from spring break. And Friday after spring break is when we'll have the unit test on all things polynomials. So the previous two, the quiz you had, the quiz you're about to take, and what we do since then on graphing polynomials. Quiz is on Tuesday. So I will see you not tomorrow on Friday, see you on Monday for the review, quiz on Tuesday. Okay. Okay, so the fundamental theorem of algebra. If you were waiting to get your first mathematical tattoo, this is sort of a letdown. You know, this is not really exciting. So every polynomial f of x has at least one solution. Okay, not too exciting, but the ones that we've been working with, our polynomials have all had real coefficients. So this is more what we've been working with. If a polynomial has real coefficients and is of nth degree, it has n solutions or roots. Now I use these words synonymously: solutions, roots, zeros. Those all mean the same thing. Those roots can be real or complex. Okay. So example, this is what degree polynomial? This is a 7th degree polynomial. How many roots will this 7th degree polynomial have? It's a 7th degree polynomial. It will have what? 7 roots. Okay. Every polynomial, a real coefficients, whatever the degree is, that's how many roots it will have. This one's a little bit tricky though, because I have it in factored form. If I hated you, I would have given you this and made you factor it. Okay. Then you would have had to factor it how many times to get it to a quadratic? 5 times. Okay. Did not make you do that, and you got some ugly numbers there. So anyway, what are the roots? Yeah, 1. That one, this one happens to occur how many times? It occurs twice. Okay. And then what are the other roots? -1, -8, 9, square root of 3, negative square root of 3. Count them up. 1, 2, 3, 4, 5, 6, 7. So there are 7 roots to that polynomial, 7 zeros. Okay. It just so happens one of them occurred twice. It had, we'll call that multiplicity, and we'll talk about that later, about what that means. Let's look at the next one. How many zeros? Well, first of all, what is the degree of this one? 4. How many zeros does it have? 4. It's 4th degree. It has 4 zeros. Okay. Okay. This one is 3rd degree. I want everybody to get this right. 3rd degree. How many zeros does it have? 3. And then it has 2 words that the other problems did not have. Find them. How do we find the zeros of this polynomial? Right. So we realize that if it has rational roots, let's start with those. Those are going to be plus or minus the factors of 3 divided by the factors of what? Of 1. So this is just going to be plus or minus, what is it, 1 and 3. Now, I look at this polynomial. Are there any shortcuts before I start? Yeah, okay. I mean, if I add those numbers, do they add to 0? I don't even have to add them to figure that out. I mean, 1 plus 1 plus 3 plus 3, without adding that, I know that does not add 0 because those are all positive. So if these numbers are all positives, my roots would have to be what? Negative. So I'm going to try -1 and -3 and see if either of those works. Okay. So let's try -1. So 1, 1, 3, 3. So if I bring the 1 down, 1 times -1 is -1, add to get 0. This is 0, add to get 3. -1 times 3 negative 3, and add to get 0. This was my x cubed, my x squared, my x, and my constant. This is x squared, x, and constant. So this means that f of x is equal to what? X squared plus 3 times what? X plus 1. So that's factored. Now, if I want to find all the roots, to find the roots, you set each factor equal to 0. So x equal negative 1. That's one of the roots. Now let's set this equal to 0. If x squared plus 3 equals 0, x squared must equal what? Negative 3. That means that x must equal what? Plus or minus square root negative 3. And what is that? Yeah, plus or minus I times the square root of 3. So my roots are negative 1, I square root of 3, negative I square root of 3. Okay, those are the 3 roots to this polynomial. It was third degree. It had to have 3 roots. We found all 3 of them. Okay. Now, if these are the roots, what are the factors? X plus 1 and what? How do I go from a root to a factor? How did you go from this being a root to that being a factor? Yeah, x minus I square root of 3 and what? X plus I square root of 3. Those are all the factors of that polynomial. Now, so I had complex roots, but my original equation, were there any complex numbers in my original equation? Right here. So, I mean, it's all real numbers, okay? So you can have real coefficients and have complex roots, okay? So the roots are not always real roots. So I'm going to skip a little bit and then come back to what you see at the top. Let's write an equation for a polynomial of least degree with coefficients, real coefficients, and roots x equal 1, 2, and negative 3. These are my roots, my solutions, my zeros, okay? So what are the factors of this polynomial? What is it? Come on, guys. Just skip ahead, guys. You can find it. What are the factors? X minus 1, x minus 2. Okay, so this polynomial is f of x equal x minus 1, x minus 2, x plus 3. Okay. Now to get to the standard form, I need to multiply this together. How do I multiply these 3 things together? Synthetic. What is the word that goes after synthetic? Division. This is not division. This is multiplication. Okay. On day 1, we talked about what to do here on this unit. What? I'm just going to multiply these things together. I'm going to pick 2 of them and multiply them together. You had an acronym for that. FOIL. So this is x squared minus 3x plus 2 times x plus 3. How do I multiply those together? Okay, I just multiply them together. What we did for organizational purposes is you said you can just make a chart like this. X squared. Pardon me? What is what? X squared minus x minus 2x, that's minus 3x. Negative 1 and negative 2 is 2, okay? So now I'm going to multiply these things together. What's x times x squared? I'm going to need participation today. What's x times negative 3x? Yeah. What is x times 2? What is 3 times x squared? What is 3 times negative 3x? And 3 times 2. Okay? So, this polynomial is f of x equal what? X cubed minus 7x plus 6. So that's the polynomial, the lowest degree polynomial that I can find that has these 3 roots. Okay? So if you'll notice what we did here, yesterday I could have given you this problem and said find all the what? Find all the roots or factors, and you would have gotten an answer that looks like this, and you would have said that these are all the roots. Okay? What are we really doing here today? We're just doing everything we did in reverse. Okay? I'm starting out with here are the roots. If these are the roots, these are the factors. Multiply together, this is the polynomial I'm talking about. Okay? So I'm just sort of backing up or doing in reverse what we've been doing for the last few days. Now, there are a couple of little corollaries we need to talk about. And, you know, I'm not going to test you on memorizing these things, but just knowing how to apply them. The complex conjugates theorem. Have we ever used complex conjugates before? When we dealt with complex numbers, we were dividing by 1 plus I, you'd have to multiply by 1 minus I over 1 minus I. Okay? So if you have a polynomial with real coefficients, and it has a complex root, a plus bi, it also must have a root of a minus bi. Okay? If it's going to have real coefficients, the only thing you can multiply an a plus bi by and get real is a minus bi. Okay? So, write an equation for the polynomial of least degree with real coefficients, having the root x equal 1 plus I. If 1 plus I is a root, there must be another root, which is what? 1 minus I. It must have both of those roots in order to have real coefficients. So, if this is the root, what are my factors? How do you go from a root to a factor? Minus that. So if 2 is a root, x minus 2 is a factor. So x minus 1 plus I and x minus 1 minus I. I can rewrite this as x minus 1 minus I, and this is x minus 1 plus I. Okay? So those are 2 roots to this polynomial. So what is this polynomial? This polynomial is f of x equal x minus 1 minus I, x minus 1 plus I. What do I do now? I what? Multiply these together, okay? So this is x minus 1 minus I, x minus 1 plus I. What is x times x? X squared. X times negative 1. Negative x. X times I. xi. Negative 1 times x. That's negative x. Negative 1 times negative 1. 1. Negative 1 times I. Negative I. Negative I times x. Negative xi. Negative I times negative 1. Negative I times negative 1. I. And then negative I times I, that's negative I squared. So what happens to this term and this term? They cancel. What about this one and this one? They cancel. Okay, everything with an I disappeared except for this one. What is I squared? I squared is?
Oh, shoot, -1.
Negative 1. I squared is -1. So what is negative I squared?
1.
Yeah, this is just 1. Okay. So this final answer is x squared. What? Minus 2x. And then it's what? Plus 2. Okay. So it's x squared minus 2x, and this is 1 plus 1. Okay. So this is the polynomial of least degree that has real coefficients. It has a root 1 plus I, and it also has to have the root 1 minus I in order for this to work. Okay, so not a lot new, but places that mistakes can be made. Okay. Now, along with those complex roots, we have another theorem that deals with irrational conjugates. If you have a polynomial with real coefficients, and it has an irrational root a plus root b, it must also have a root a minus root b. When have we seen things like, 1 plus root 2 and 1 minus root 2? When did we see things like that? When we were doing what? No, not complex, but when we were doing what? Yeah, quadratic solutions, but when we saw them in denominators of fractions, what did we have to do? Rationalize, that's the word. Rationalize in the denominator. Whenever you saw a 1 plus 2 in the denominator, you had to multiply by 1 minus 2 over 1 minus root 2 over 1 minus root 2. Okay? Same thing here. If 1 plus root 2 is a root to a polynomial, what else must be there? 1 minus root 2. That has to be there. Okay? If these are the roots, then what are the factors? The factors are x minus 1 plus root 2 and x minus 1 minus root 2. So this is just simply x minus 1 minus root 2 and x minus 1 plus root 2. Those are the two factors to this polynomial. So this polynomial is f of x equal x minus 1 minus root 2 and x minus 1 plus root 2. How do I get this to its standard form now? I've got to multiply all this together. So x minus 1 minus root 2 and x minus 1 plus root 2. X times x, x squared. X times negative 1, negative x. X times root 2. That's, yeah. It's okay, right like that. What's negative 1 times x? Negative x. Negative 1 times negative 1. 1. Negative 1 times root 2. Negative root 2. Negative root 2 times x. Yeah. Negative root 2 times negative 1. Root 2. Negative root 2 times positive root 2. What's square root of 2 times square root of 2? 2. What's with a negative in front of it? It's negative 2. Okay. So this polynomial is x squared, what? Minus 2x. And then what happens to this? Cancels with this with this, and what's 1 minus 2? Negative 1. So x squared minus 2x minus 1, that's a polynomial that has the roots 1 plus root 2 and 1 minus root 2. Okay? Let's do a few more of these before we call it a day. The big thing here is just staying organized, okay? Give the equation of a polynomial of least degree with real coefficients and roots negative 1, 2, and 4 plus root 3. Based on those roots, is there another root that has to be there? Which one? Which one? Right, so it's going to be 4 minus root 3 has to be there. Okay. If 4 plus root 3 is a root, then 4 minus root 3 has to be a root. So f of x is equal to, what are all the factors now? X plus 1, x minus 2, yeah, and then x minus 4 minus root 3, and x minus 4 plus root 3. Okay, those are the roots of this polynomial. What degree is this polynomial? 4. I'm going to multiply x's 4 times. I'm going to get a 4th degree polynomial. Now, what do you want to multiply first? Okay, that's the easier thing. And then, why do I not multiply this one times this one, or this one times that one? What's going to happen when these two multiply? What should go away? The square root should go away. So I want to keep those together, okay? But let's multiply these two things together. So f of x equal x squared, what, minus x minus 2 times x minus 4 minus root 3, x minus 4 plus root 3. So I can't avoid it forever. What do I have to multiply now? Yeah, these last two things, I'm going to have to multiply these things together. So x minus 4 minus root 3, x minus 4 plus root 3. Easy question. X times x, that's x squared. X times negative 4, that's negative 4x. X times root 3, that's just x times root 3. Negative 4 times x, that's negative 4x. Negative 4 times negative 4, 16. Negative 4 times the square root of 3, that's a negative 4 root 3. Negative root 3 times x, that's negative x root 3. Negative root 3 times negative 4, that's 4 times the square root of 3. What is, yeah, so negative, what is square root of 3 times square root of 3? 3. Stick a negative in front of that and you get negative 3. Okay, so this tells me that f of x equal x squared minus x minus 2. What do I get from here? X squared how many x's? Minus 8x and plus 13. Because what happens is that cancels with this. If you're doing this right, all of your square roots, all of your complex numbers go away. Now what do I have to do? I got to multiply these two things together. So this is x squared minus x minus 2, x squared minus 8x plus 13. What is x squared times x squared? X to the 4th. What is x squared times negative 8x? Okay, I need participation. What is this? Negative 8, what? X cubed. What is x squared times 13? 13x squared. What is negative x times x squared? Negative x cubed. Negative x times negative 8x. 8x squared. What is negative x times 13? It's negative 13x. Okay. What is negative 2 times x squared? And negative 2x squared. Negative 2 times negative 8x. 16x. Negative 2 times 13. Negative 26. This final answer, f of x, is x to the fourth. And then what? How many x cubes? Minus 9 x cubed. And then x squared's 19x squared. And what? 3x minus 26. That is a fourth degree polynomial with roots of negative 1, 2, 4 plus root 3, and 4 minus root 3. Okay. So these are all things we've done before. Complex conjugates, irrational conjugates, multiply binomials, multiplying trinomials, roots, factors, okay? We're just putting together in problems that take a long time and you can make arithmetic mistakes. But you guys are good with not doing that, okay? Questions over this, okay? So you see, anytime there's a complex root, you've got to have the complex conjugate also as a root in order to have real coefficients. Same thing with irrational. One last one here. Write the equation for the polynomial of least degree with real coefficients and roots at 3 and 2 plus I root 3. Okay, based on this information, what other root has to be there? 2 minus I root 3. Okay, and you see here I've got a combination of complex and irrational. Okay, so what is this polynomial then? F of x equal, x minus 3, and then x minus 2 plus I root 3, and then what? X minus 2 minus I root 3. What do I do? Which ones do I multiply first? Yeah, the last two. You can make your life hard if you multiply these two together and then multiply by that, okay? You want to get these square roots and complex numbers to go away as quickly as possible. That was designed to make that happen. So, x minus 2, and then I root 3, and then x minus 2 minus I root 3. X times x. X squared, okay? And x times negative 2. Negative 2x. X times negative I root 3. That's just negative x I root 3. Copy all that stuff down. Negative 2 times x. Negative 2x. Negative 2 times negative 2. That is 4. Negative 2 times negative I root 3. That's 2I root 3. X times I root 3 is what? xi root 3. I root 3 times negative 2. Yeah, negative 2I root 3. And then here, negative, it's I times root 3 times negative I times root 3. So let's just do this one separate. So negative I root 3. What's root 3 times root 3? That's 3. What's I times I? That's I squared with a negative. What's I squared? Negative 1. What's a negative negative 3? Believe me, that's a place that a mistake could be made, okay? So negative I times I is negative I squared, which is 1, and then root 3 times root 3. So let's pull all this together. Now, if you've done this right, what should go away? Negative xi root 3 should cancel with xi root 3. 2i root 3 should cancel with negative 2i root 3. Every square root, every complex should go away. That was the whole purpose of doing that. So now what have I got? I've got f of x equal x minus 3 times x squared minus 4x,
Plus 7.
yeah, plus 7.
Ooh, nice.
What do I do now? Now suddenly this looks like an easy problem, okay? So it's x minus 3, x squared minus 4x plus 7. X times x squared, x cubed. X times negative 4x, yeah, negative 4x squared. X times 7 is 7x. Negative 3 times x squared, yeah, negative 3x squared. Negative 3 times negative 4x, but 12x, right? Negative 3 times 7, negative 21. So my final answer, drum roll please, is what? X cubed. Then what? Yeah, minus 7x squared plus 19x minus 21. Okay, that's it. That is the polynomial of least degree that has these three roots or zeros. Okay. So again, what we really were doing was we're doing these solutions that we have been doing. We're doing them back, and we're starting with a root or factor, getting to the polynomial, pulling in what we had done previously with complex conjugates and irrational conjugates. Okay.